So now we're doing limits number 1, number 4. So again, we're talking about taking our time interval and keeping our interval centered at 25, but using shorter and shorter increments of time. So they're going to use 5 seconds, 1 second, 1/10 of a second, and 1/100th of a second. And we're going to see if we observe a trend or a pattern as we do that. All right. So one of the things that's tricky about this way I've worded this is you have to, it's not obvious what these time intervals are. So let's have a look at the timeline and see if we can get a better handle on that. So I'm going to draw my timeline horizontally this time, which is more traditional. So there's my 25 seconds at the center. So my first interval is going to be centered at 25, but the length of that interval is going to be 5 seconds. So what does that mean in terms of my interval? I have an interval that is 5 seconds long, and so where does it begin and end? What are the end points of this interval? So since it's 5 seconds long, each half of it is 2.5 seconds long. So that means the first end point is 22.5 seconds, and the ending point is 27.5 seconds. So that was the first trick in number 4, is to get what these intervals really are. So for part A, my interval, and I'm going to note this time what each time interval is, since they're not quite as obvious. So my first interval is not 24.5, but it is 22.5 to 27.5. That's my first interval. All right, so now the last time that I did this, I calculated y of 27.5 and y of 22.5 separately. I'm going to show you another way that we could lay that out that's a little more concise and also leads us in the direction of what we're really after here. So if I come back to the idea that the rate is delta y over delta t, the change in height over the change in time, then what that really, I can just keep that in fraction form and say this is y of 27.5 minus y of 22.5 over, now the delta t, the time interval, I already know it's 5 seconds, but I'm going to be really goofy here and just write out 27.5 minus 22.5. Now you don't have to do that, but I did that because I want to show this analogy that what we're really looking at is the slope formula. It's y2 minus y1 over x2 minus x1. You're going to see a lot of ways in which everything we do in calculus comes back to that slope formula. So we could have just put 5 down there right away, but I didn't because I wanted to show how this is related to the slope formula. All right, now, to calculate this, I'm going to remember that I've already got the equation still in my y equals. I'm going to show you some more nifty new calculator tricks. So this one, if you haven't seen this before, you're going to love it. I'm going to show you a calculator trick, by the way, and so one thing that I want to mention is that if you have an older TI-84, it might not do this. This might not work. However, if you have the older TI-84, and if some of the tricks I show you don't work, take your computer, navigate to the TI website, find download operating system upgrade, something like that. So I don't know exactly what it's called. I've never done it. But it's something like find on the TI website an upgrade for the TI-84 operating system. Then get yourself one of the cords that plugs into that kind of a end, and then plug that into the USB in your computer, and you can download and upgrade the operating system, and then it will do all these nifty tricks. If you have a TI-83 or earlier, sorry, you're not going to get the nifty tricks, and you're going to have to do a lot of things that require a more difficult syntax, and I'll try to show those for anybody who needs them. All right. But for now, I'm going to hope everybody's got an upgraded TI-84. The upgrade is from quite a while ago, so you probably have it. You probably don't have to worry about it. So what you want to be able to do is hit Alpha F1, and you get all these funny looking choices here. Now you can explore what these do. We're really interested in this first one first, n over d. So I just press that, and look, it gives me a fraction. Now look what I can do. I can go, so remember the vars, y-vars thing? So if you get good at that, you can do that quickly. Vars, y-vars, function y1. y1 of 27.5, 27.5, close parentheses, and then I'm going to go minus vars, y-vars, function y1 of 22.5. There. Now in the denominator, for the purpose of writing this, wanted to do this to illustrate a point, but we know it's 5 because the length of the interval is 5 seconds. That's what the delta t is. So I'm just going to put 5 down there. You could put this if you wanted. Same thing. I hit enter, and I've already got my result of negative 2,201.0625 meters per second. So you see how quickly that can go if you take advantage of everything your calculator can do. So I want to go ahead and look at the part B, interval for part B. So this time, the interval length is 1 second. So what's that going to look like, and what is my actual interval going to be? I'm going to have a time duration that is 1 second instead of 5 seconds, but still centered at 25. So what are the endpoints of the interval? Where here I'm going to have 24.5 seconds, and here I'm going to have 25.5 seconds. So I'm going to keep consistent with the way I laid this out by first writing what the interval is, 24.5 seconds to 25.5 seconds. Then I'm going to write r equals delta y over delta t. You know, it's really just nice to, even though I'm being redundant, I'm showing where things came from. And I can take a lot of shortcuts, but show where things come from. So this is now going to be y of 25.5 minus y of 24.5 over... I'll go ahead and be consistent. You could have, of course, just put 1 down there. All right. So now, again, taking advantage of what the calculator can do, I'm going to go up here, highlight the expression that I already had, press Enter, and now I just edit this line up. So I can go make this one 25.5 and make this one 24.5. Down here, I could just start over it because I don't need the fraction because it's just 1. But I want to keep things simple, so I'm just going to preserve that structure because the next one's going to be 0.1. I want to be able to copy and paste. So enter, I get negative 2194.0425, negative 2194.0425 meters per second. So that's how you're going to do this A, B, C, and D. If you had trouble getting started, or you just chose incorrect intervals, or you weren't sure what to do with it, or you got numbers that are not these numbers, go back before you go to the next video. Go back and fix C and D and fill in the chart, and we'll discuss it all in the next video.